with phase diagrams, there's a couple things we're going to talk about. Okay, so specifically with phase diagrams, everybody, they're showing us temperature and pressure. Okay, they're always going to show us temperature and pressure. And based on this, right, the temperature and pressure, this was going to show us how our matter, right, our states are changing depending on if it's higher, lower temperatures, if it's high or low pressures. Okay. Now there's 4 definitions that we're just going to talk about that I want to expose you guys to before we dive into this diagram. Look, another chart, another diagram. I'm telling you, you learn so much from these charts and diagrams. So the first definition is critical temperature. Critical temperature is basically a temperature that's above which a substance is always a gas. Okay, so basically, if you're at a critical temperature, anything above is going to say a gas. Critical pressure is basically the pressure needed to make liquid. Okay, to make it a liquid at that critical temp. Okay, so it becomes a liquid once it's at this critical temperature, right? Remember that. So it's at the critical temperature. So basically, you're going from that gas to a liquid. Okay, that's a critical pressure. Critical point is basically where we got our intersection of the critical temperature and pressure. Okay, so that's the critical point, the intersection. And then we got one more point we're going to cover here, triple point. Okay, so this is when we have a single point where all 3 phases will coexist. And that does exist, okay? All right, so let's look at our phase diagram for water. Okay, so we got water here. Water, right? We got our phases here. We got our solid, we got our liquid, and we got our gas. Okay, so we're seeing with our phase diagram all of our phases, you know, and the diagram is just showing us what we already kind of, you know, went over before with the heating curve, right? Because we understand, right, that you heat something up, especially with water. So if you heat water up, it's going to start boiling at 100 degrees. We know that, but the phase diagram is going to help us look at that. Okay, it's going to help us look at it. So we got our pressure. We got our pressure, right, on our y-axis, and then we got our temp on the x-axis. Okay, so let's just start somewhere. Okay, a whole bunch of stuff going on here. Let's start with solids. Okay, so with the solid, right, everything from this point and to the left is considered going to be in a solid phase. Okay, so if I'm going from a solid to a gas, we're going to see that this is the sublimation curve. Okay, so we can see, right, if you're going from a solid to a gas, what are we seeing here? Our pressure is decreasing and our temperature is most likely increasing. Okay, we got our fusion curve right here. So this is telling me, okay, I'm going from a solid to a liquid. Okay, so basically, what are we seeing over here? Temperature most likely is going to have to increase, right? As well as our pressure is increasing as well. So we're probably going to have to be at a high pressure, something over 760 torr. Okay. And then, all right, let's look at our liquid. Our liquid basically is going from a liquid to gas, vaporization, right? So we usually are seeing higher temperatures, okay, and the pressure's pretty low in the middle, okay, basically there. And then we can see how huge, right, gas is. Triple point, we can see the triple point of all of our solid, liquid, and gases here. And then we got our critical point. And once again, this critical point is where we're intersecting. Okay, so we have our critical temperature and critical pressure at this intersection here. Okay, now anything beyond this is called supercritical fluid. We're not really going to go over supercritical fluid. This is something that's advanced. If you guys want to know about supercritical fluid, I can. Just let me know in the comments.